building a solid enterprise data and analytics solution. Now, we know our listener, the learner, wants to get the core knowledge, quickly and thoroughly, but without feeling totally overwhelmed.
Right. Cut through the noise.
Exactly. So our mission today is to unpack this, pretty comprehensive checklist. It covers basically everything from where data starts all the way to getting insights out. Think of it like a roadmap for the whole data journey.
That's a good way to put it. And what's really useful about this kind of checklist, I think, is that it works across the board.
How so?
Well, whether you're building on your own servers, going all in on the cloud, or maybe doing a bit of both, a hybrid setup.
Okay.
And even if you're using different tools, big vendor stuff or maybe open source options, these core ideas, they still apply.
Yeah.
We're really aiming to pull out those key sort of aha moments.
Aha moments. I like that. A shortcut to being properly informed.
Hopefully.
Yeah.
A shortcut to understanding what's really involved.
Okay, great. Let's dive in then, starting right at the beginning. Data sourcing. Getting the data in the first place.
Step 1.
The checklist kicks off by saying you absolutely have to identify and, crucially, document every single data source. Internal ones, external ones.
Databases, APIs.
Right. APIs, those messengers between systems, files, even streaming data coming in constantly.
Okay.
But it's not just finding it, is it?
No, not at all. You got to make sure you actually have permission, the authorization to use it. And does it even make sense for what the business is trying to achieve? That alignment is key.
Yeah, you wouldn't want to build on shaky ground like data you shouldn't even have access to.
Exactly. That's a non-starter. And right after that comes connectivity and checking the format.
Okay, so can your systems actually talk to these sources?
Precisely. Do you have the network access, VPN setup, the right API keys like digital passwords, and then the formats? Can your tools actually read the data? Is it simple CSVs or are you dealing with like JSON, SQL databases, maybe a mix?
It could be anything, really.
It often is. And for those hybrid setups, part on-prem, part cloud, secure connections like data gateways or specific connectors become absolutely vital. You need that bridge.
Right. Makes sense. So you've connected. Now you need to understand the structure. Yeah. That's schema validation.
Spot on. You need the blueprint, the schema for each source. And then you check, does it match what you expect?
Like, are the column names right? Is age a number, not text?
Exactly that. The checklist mentions using automated tools here, which honestly can save a ton of time. They catch weird inconsistencies early.
I've heard of schema drift, where the structure just changes on you.
Oh yeah, that's a classic problem. Schema drift can break everything downstream if you're not watching for it. Imagine building a whole report and then poof, a column type changes.
Nightmare. So schema validation helps stop that, which flows nicely into data profiling and quality checks.
This is where you really start digging in. What do the values look like? Are there lots of missing bits? Weird outliers?
You mean understanding the data's personality?
Kind of, yeah. The checklist hammers home implementing actual data quality checks for completeness, accuracy, consistency, even finding those pesky duplicates.
Duplicates, everyone's favorite problem.
Tell me about it. And studies show poor data quality costs businesses serious money. So this isn't just tidying up. It has a real bottom line impact.
So it's not just finding the problems, it's defining what good data looks like for your business.
Exactly. Setting up specific business rules, like maybe an acceptable salary range or a standard format for product codes.
Okay.
And then importantly, setting up alerts if data comes in that breaks those rules. It's about being proactive.
Proactive data health monitoring. I like it. Builds trust, I guess.
And absolutely builds trust. If you know the input is good, you can trust the output, the insights. And flowing from that is data lineage capture.
Lineage.
Yeah.
Sounds technical, but it's basically tracing the data's journey.
That's it. From where it started through all the changes it goes through.
Yeah.
The checklist says, rightly, start this early.
Why early?
Well, trying to reconstruct lineage later is painful. Doing it from the start saves massive headaches, especially for audits. Or figuring out why a number looks odd.
It's like a history book for each data point.
Yeah.
Crucial for traceability, accountability, and compliance, I imagine.
Absolutely essential for compliance. Now, shifting gears slightly, but still in sourcing performance.
Speed.
Yep. The checklist brings up performance benchmarking during ingestion. Can your pipelines actually handle the amount of data you expect?
Within the time you need it, like overnight batches or meeting SLAs.
Exactly. You need to test that with realistic data volumes. And for cloud users, it mentions keeping an eye on things like I/O throughput and scaling resources up or down as needed.
Right. You don't want ingestion to be the bottleneck slowing everything else down. Okay, another huge one, security and access control.
Paramount.
Always.
The checklist talks about classifying data public, internal, confidential, regulated, and then applying least privilege.
Meaning only give access to those who absolutely need it. Don't just open the floodgates. And it distinguishes between securing on-prem versus cloud data, right? No hard-coded logins.
Please no. That's a huge risk.
Yeah.
Security needs to be baked in from day one, not sprinkled on top later.
So how does that look practically?
Well, on premises, you might use things like SSH for secure access, maybe IP whitelisting. In the cloud, it's often about using IAM roles, identity management. A common mistake is giving permissions that are way too broad. Big vulnerability.
Got it. And tied closely to that is encryption in transit, protecting data while it's moving.
Critical, especially over public networks. The checklist mentions the usual suspects: HTTPS SL for web traffic and APIs, SFTP for secure file transfers, maybe BNTLS for database links.
And this isn't just nice to have, it's often required, isn't it? IPA, PCI-DSS.
Oh, absolutely. Mandatory in many cases. Which brings us neatly to the final point in sourcing, the specific compliance check.
Tying it all together based on the data type.
Exactly. The checklist gives good examples. GDPR for EU data means things like consent and transfer rules. IPF for healthcare means stuff like business associate agreements, only using the minimum necessary data.
And PCI-DSS for payments.
Big one there is avoiding raw card details if you possibly can. Don't ingest or store sensitive stuff like the CVV code. There was this case, a big fine actually, where a company just didn't handle GDPR consent properly. Real world consequences.
Okay, wow. So that's sourcing covered. We got the data in securely and compliantly. Now what? Data modeling, right? Storing and transforming it.
Yep, making it useful for analysis.
Yeah.
The checklist starts by saying, define your model requirements first. How are you going to structure this data?
For reporting, machine learning, both.
Exactly. Will it be a data warehouse, a data lake, maybe both a lakehouse? And crucially, will it work with the analytics tools you plan to use?
The why behind the model. What questions need answering? Who's using it?
Precisely. Those answers guide your modeling approach. Then the checklist walks through that classic choice, dimensional versus normalized models.
The star schema versus third normal form debate.
Kind of, yeah. It highlights the trade-offs. Dimensional models, like star schemas, are often more intuitive for users, faster for queries. Normalized models are great for reducing redundancy, often seen in operational systems. Key thing is documenting why you chose what you chose.
Makes sense. Then you actually design and build the schema. For a warehouse, that means fact tables, dimension tables.
Setting up primary keys, the unique IDs, and foreign keys to link tables. And don't forget, indexes for performance.
Got to make those queries run fast.
Absolutely. And the checklist stresses validating the build against the design. Does it match? Does it align with the source data? Are the relationships right?
Okay, structure is built. Now you fill it. Data transformation, ETL or ELT.
Right, extract, transform, load, or extract, load, transform. Basically defining how you'll clean and integrate the data.
Like calculations, summing things up, applying business rules.
All of that. But it's not just doing it. Technical validation is key. The checklist mentions unit testing transformations with sample data, making sure they work as expected.
And checking within the pipelines, too, to catch data that breaks the rules.
Yes, build validation right into the flow. Don't just move data, shape it, clean it, verify it.
Which ties straight back to data quality, but now within the model itself.
Exactly. The checklist says, implement automated checks after loading. Verify record counts. Check for missing values, values out of range. Make sure those table relationships, referential integrity, hold up.
And have a plan for bad data. Reject it, quarantine it, alert someone.
You need a process for exceptions. A clean, consistent model is the foundation for everything that follows.
Okay. And performance comes up again here, doesn't it? Benchmarking queries.
It does. You need to test how well your model performs with typical analytics queries and reporting loads. Can it answer questions quickly, even with lots of data?
Don't want users waiting ages for a simple report.
Nobody does. The checklist mentions common optimization tricks.
Yeah.
Indexing, partitioning large tables, maybe clustering related data physically closer.
Lots of ways to tune it. And as data grows, you need a plan for where it lives long term, right? Storage and archival.
Absolutely. Where will it be stored? On-prem servers? Cloud storage services? Maybe tiered storage for cost savings?
Need backup plans too, presumably.
Definitely. Regular backups. and an archival strategy for older data to meet retention rules and keep costs down, especially in the cloud where storage isn't free.
Efficient storage management is key. Let's loop back to security and privacy within the model.
Important layer. Encryption at rest for sensitive data is crucial. So is role-based access control, or RBAC, on the model itself.
So controlling who can even query certain tables or columns?
Exactly. And the checklist brings up data masking or tokenization.
What's that?
It's about replacing sensitive data, like personal info, with fake but realistic-looking data in non-production environments, like dev or test. Protects privacy while still letting teams work.
Smart. Protects real data leakage. Add lineage again, tracking into the model.
Yep, extend that tracking. How did this value in the final table get derived from the source? And maintain metadata catalogs.
A dictionary for your data.
Essentially, yeah. Information about your data definitions, sources, owners. Crucial for governance and understanding the impact if something changes.
Fundamental for governance. Okay, final compliance check, this time for the modeling stage.
Right. GDPR, think privacy by design. Only store what you need. Consider pseudonymization. Be ready for data subject requests.
Like show me my data or delete my data.
Exactly. PCI. Secure those databases with health info, PHI. Strict access controls. Audit logs are vital. Secure key management for encryption.
And PCI-DSS for payment data in the model.
Don't store sensitive authentication data, ever. Use strong encryption, maybe tokenization, for card numbers, PANs. Limit access strictly. Segment that card data environment.
Got it. Okay, phase 3. We've sourced, we've modeled. Now let's get insights, data visualization and analytics.
The payoff, first step. Tool selection and integration.
Choosing the right BI tools, dashboards, notebooks.
Yeah, tools that fit your needs and your user skills. And making sure they can connect properly to your data model and sources. Again, considering on-prem, cloud, hybrid needs, maybe needing data gateways.
Tool choice matters. Then figuring out what to show. Dashboard requirements.
Crucial. What KPIs does the business need? What drill downs are required for deeper exploration? Designing clear visuals that the model can actually support.
And remembering basic design principles. Clear labels, right chart types, don't make confusing charts.
Please don't. A confusing chart is worse than no chart. Then you actually build them.
Develop the visuals, maybe with sample data first.
Good starting point. Then, the critical part. Technical validation. Do the numbers on the chart match the underlying data? Cross-check everything.
Test the filters, the drill downs.
Absolutely. And super important, get end users involved. Do these visuals actually make sense to them? Do they provide the insights needed?
User validation makes total sense. Just because it looks pretty doesn't mean it's useful or correct.
Exactly. And performance matters here too, of course. Load testing the BI layer.
Testing dashboards with realistic data volumes. Simulating lots of users hitting it at once.
Yeah. Measure load times, responsiveness. Is it sluggish?
What if it is?
Optimization time. Tune the queries, feeding the dashboard. Maybe create summary tables with pre-calculated results. Use caching. Scale up the server resources. For Cloud BI, you often have performance tiers with different costs.
Trade-offs there. You definitely don't want slow dashboards driving users crazy. Okay, access control again, but for the visuals.
Yes. Fine-grained control. Who sees which dashboard, which report? Maybe even row-level security, so different users see different data rows within the same report based on their role.
Like a sales manager only seeing their team's data.
Precisely. Setting up user groups for easy distribution and regularly reviewing who has access to what.
Security follows the data all the way to the screen. What about data freshness? How up to date are the visuals?
Key question. Define refresh schedules. Is it near real time?
Yeah.
Hourly, daily. And verify those refreshes actually work reliably.
Set up alerts for stale data.
Good idea. Ensure consistency with the source systems. You need confidence the reports reflect reality.
Totally. Security points specific to visualization.
Yeah. Securing any data extracts or caches the BI tool might create locally. Ensuring cloud BI tools meet your security standards, data residency certifications. Hardening any open source visualization tools you deploy.
Security everywhere. And the compliance check for visualization.
Right. GDPR, privacy controls and dashboards. Ability to suppress or anonymize personal data if needed, like for right to be forgotten. Avoid showing unnecessary personal data. Audit trails of who viewed what personal data.
Okay. HIPAA.
Restrict access to PHI visuals strictly to authorized people. Secure any exported reports containing PHI. Need that business associate agreement, BAA, with cloud BI vendors handling PHI.
And PCI-DSS and visuals.
Avoid showing full card numbers. hands. Mask or truncate if absolutely necessary. The BI system itself shouldn't store cardholder data locally unless it's fully PCI compliant, which is a high bar. Strict access control, monitoring, logs.
Okay, deep breath. We've sourced, modeled, visualized. Now the final push, implementation and deployment, getting it live.
Making it real starts with infrastructure provisioning.
Setting up the servers, network storage, different for on-prem, cloud, hybrid.
Exactly. On-prem, physical hardware, capacity planning, cloud. Provisioning resources, maybe using infrastructure as code for consistency, following best practices like using subnets, security groups, hybrid, secure connectivity, testing that connection's speed and reliability.
And setting up the environments. Dev, test, prod.
Critical step, distinct environments. Dev and test need realistic but anonymized or dummy data. Production needs production-level security hardened from the start.
Don't test and prod. Next, CI/CD. Continuous integration, continuous delivery.
Huge value here. Automating the build, test, and deployment process. Using version control like Git. Reduces manual errors, speeds things up, makes releases more reliable.
Automation is your friend, then serious testing, end-to-end.
Comprehensive testing of the entire pipeline. In a staging environment that mirrors production, using realistic data volumes.
And user acceptance testing, UAT. Getting business users to sign off.
Essential. Does it meet their needs? Does it work as they expect? And the checklist also mentions failure scenario testing. What happens if a component breaks? Does it recover?
Testing for resilience. Good point. Then more performance testing. Stress testing the whole system.
Yep. Under peak load conditions. Simulate busy periods. Benchmark the latency from data source all the way to the user seeing it. Identify any final bottlenecks. Ensure you're meeting those SLAs.
Make sure it won't fall over on day one. Before launch, security hardening.
Absolutely critical final check. Apply latest patches. Disable default accounts, unnecessary services, lock down network rules, firewalls. Run vulnerability scans. Set up security monitoring.
Final security polish. And planning for disaster.
Yeah.
Backup and recovery.
Non-negotiable. Regular automated backups of critical data on-prem and cloud. Document a recovery process. And test the recovery process regularly. Can you actually restore within your target time, RTO? And data loss tolerance, RPO.
Testing the restore is key. Don't just assume backups work. Need to back up configs and code too, right?
Good point, yes. Not just the data. And once it's live, it needs ongoing care, monitoring, and maintenance.
Watching pipeline health, system performance, having plans for incidents.
Exactly. Robust monitoring. Clear incident handling procedures, a regular maintenance schedule. This is where data ops practices come in, treating data pipelines like software products with ongoing support.
It's a living system.
Yeah.
And governance needs to be operationalized too. Data stewards.
Yeah. Assigning responsibility. Data stewards overseeing quality, approving changes, maintaining metadata, having clear policies for the data lifecycle.
Keeping it organized and managed. Then, one last compliance check before hitting the go button.
Final verification. For GDPR, documentation ready, consent handled, DPIA done if needed, protections verified. Required safeguards documented. Risk analysis done. Policies, training records, EPHI security confirmed, audit logs working, incident response plan ready.
And PCI-DSS.
Completed your self-assessment or audit. All 12 requirements demonstrably met. Firewalls, no defaults, secure storage, encryption truncation, strict access, security updates, monitoring, documented evidence for everything.
Thorough check. Okay, finally, the launch itself. Rollout plan.
The go-live moment. Final data load or sync. Switching over DNS or connections. Communicating clearly with users. Maybe a phased rollout, start with one department, then expand. Ensure support teams are ready for questions or issues.
Smooth transition, hopefully. And the very last item, post-deployment review.
Yes. After it's been running a bit, circle back. Gather user feedback, review logs, performance, address any teething problems. It's about continuous improvement learned from the launch.
Makes sense. Yeah. So wrapping this up, it's crystal clear, isn't it? Building a proper enterprise data and analytics solution isn't trivial. It needs that meticulous planning, real attention to detail at every single stage, just like this checklist lays out.
It really does.
Yeah.
And what strikes me is how interconnected it all is. You know, a slip up way back in data sourcing can cause ripples right through modeling, visualization, and even your compliance.
Yeah, a weak link breaks the chain.
Exactly. But by thinking through all these steps, hopefully our listener, the learner, now has a much clearer picture, a deeper feel for what's really involved in building something robust and crucially compliant.
Absolutely. So here's a final thought for everyone listening to chew on. Looking back at this, well, incredibly detailed checklist, Which specific part do you think gets underestimated the most often in real-world data projects? Where do teams tend to cut corners, and what are the potential consequences down the road?
That's a great question to ponder. And we definitely encourage listeners to dig deeper into any areas that caught their interest today. Maybe look into specific data governance frameworks or cloud security best practices, or get really into the weeds of GDPR or HIPAA if that's relevant to them.
For sure. This deep dive gives you a solid foundation, a map really, but the territory itself is always changing.
Constant learning, meticulous work. That's the key to success in this space.
Well said. Thank you for joining us for this deep dive. We hope it's given you that valuable shortcut to being well informed. Until our next exploration.